This episode is Teach Me series, and we learn the basic of Kirchhoff's rule. Kirchhoff's rule, sometimes referred to Kirchhoff's circuit law, and a pair of the rules used typically to analyze DC circuit. The first rule that we examine Kirchhoff's junction rule. The junction rule states that the sum of current flowing. The sum of current flowing, and yes, I know it. Current flowing is a redundant, but anyway, the sum of current flowing into the junction equal the sum of current flowing out of said junction. Mathematically speaking, current in equal current out. And sounds simple enough, right? And let's take a look at circuit diagram for junction to illustrate our rule. A diagram. We take simple three-way junction and label J1. We draw the current flowing into the J1 from the left, it called I1, and current flowing out to the right and down, I2 and I3. How exactly we decide the direction and the label J1 and we apply to the circuit? We have current in is I1 equal current flowing out I2 plus I3. And that's how the junction rule is applied to the junction before we move on to point out. Kirchhoff's junction rule is just a consequence of physically significant principle, namely principle of conservation of charge. And so we can sort of think as the J1 as a fork in the road where the car, I mean the charge. Kirchhoff's junction rule is the charge either continue traveling to the right or turn and move down. Got it? Good. Okay, now let's examine Kirchhoff's other rule, the loop rule. The loop rule says that for any closed loop, the sum of voltage leap equal the sum of voltage drop. And mathematically said that the voltage closed loop equals 0. Okay, now let's examine the simple circuit to see how we apply the voltage rule. Let's take a look at the diagram. We take a simple circuit, and here we have a voltage across the V surface, and here we cross across the resistor reservoir. Side is simple circuit. We have a singular current and its direction of positive voltage flow clockwise. And this is loop A. Okay, next level. Our circuit loop A. To apply to the loop, A will be traveling clockwise around the loop. Summing voltage starting on the bottom left, we have positive V sub S and lift, and V sub R drop. Okay, we apply to the circuit. Lift or drop. V sub S negative to V sub R equal 0. And that's how we apply to the rule. By the way, Kirchhoff's rule, like the junction rule, has a physical root in the conservation law, namely the principle of conservation of energy. Okay, let's now discuss the convention associated with Kirchhoff's rule. Convention for Kirchhoff's rule. The first two conventions relate to the rule and identify voltage, lift and drop. If we travel a battery while summing voltage, and we go from the low high low to high is positive to negative. Then the voltage of the battery is treated as a positive voltage. It's because increase the electrical potential. If instead we travel toward the battery, high to low, high to low. That is positive to negative. The voltage is treated as negative, which we call voltage drop, and because the increase in electrical potential is drop. Okay, so from voltage source, low to high, we have positive voltage, lift, and high to low, positive voltage drop. It turns out that the size of the voltage across a resistor also depends on the direction of the level current. So, if you follow a current toward the resistor, then the voltage across the resistor is treated positive item or negative voltage lift. And follow the current as for pass toward resistor, then voltage across the resistor to treat a positive I time negative voltage. Then we positive IR. If you current the resistor negative is drop and positive IR is lift. This is the best path. The direction of loop and currents are excite and separate or be ready with absolutely no preference in direction. So long, the circuit of correctly analyzed using Kirchhoff's rule, the actual direction of positive charge and flow will be revealed in our result, with it to say that if I1 end up having a negative amperage, and we know that positive charge for the opposite way we reveal it kind of like a choose your own vector is this column. Okay, one final convention relating to labeling our circuit diagram. Typically, we use one more loop than the number of junctions in the circuit. Okay, so we should to have enough of them level before applying to the Kirchhoff's rule. I'm Jessie Mason. I hope you find the video too helpful. If you have any suggestion for future teach me video or just want to say hello from the past of the world, and please do so in the comment below. As always, happy learning. Thank you.